Okay, so for this video, we're gonna go over the LeetCode project 295. Find the medium from data stream. The medium is the middle value in an order integers list. If the size of the list is even, there is no middle value, and the median is the mean of the two middle values. So the mean is the division, like the addition plus the division. So for example, for a list of numbers, integers 1, 2, 3, and 4. Since it's odd, it will give us the center one, so we get 3. And in a one that is two values, or let's say it's an even, then we get the closest two to the center. We add them, divide them by 2, and that's our median. So how are we gonna approach this solution? We're gonna approach it with heaps. So first, we're gonna look into our list. We're gonna start with like a low list and a high list. So we're gonna divide our list into two. So whatever we get, a 3, a 2, or whatever, we're gonna find out the length. We're gonna compare if the low and the high lengths are similar, and then we're gonna perform our for loop or our operations with the heaps. So what is a heap? So a heap is kind of like a container, right? That is typically the heap minimum. So what it does is it's a container that, imagine it as something that you're gonna put in numbers. It's gonna arrange them, and it's gonna give you the smallest number of those positive numbers, right? So let's say if we have 2, 3, and 4, like here, it will put everything in the container, and it will give us these as their 0. So if this is called container, then this will be, to access the number 2, we just do the 0 in brackets, right? So that is our one. And then this is to check the minimum value of, like, let's say the highest numbers, right? But then if we want to check the lowest numbers, we need to get the lowest value of the lowest numbers. So then we multiply it by negative. So then let's say if we have, let's do a new list of, let's say 1, 2, 3, 4, something like that. So if we have 1, 2, 3, and 4, right, and we have this list, then we will do here, it will be pretty much like this. And then this list, since it's a minimum heap, it will take the 3 here and the 4 here. And since this is looking for the minimum value, this is -1, inside is -2. So this is the lowest value and the lowest value, right? It's just that we multiply these values by negative, so then we get the lowest value first. So it's just like a trick on heaps to get these values. So okay, so let's say we have our heap, the low and high, and these are gonna be our dictionaries, or well, our lists, right? And then we're gonna start our loop. And let's say for this specific one, our loop will start with 2. We will send it here. We will make it negative. We take it out. We send it to, since we already know it's 3 numbers, we know that the higher one is going to be more numbers. We gotta decide that one list is always going to have larger numbers. So we're going to go with high. So then we know that we're going to have 2 numbers here, 2 numbers here, right? So first one is going to go there. It's going to go here. Then it's going to stay there and get out of here. So then the 3 moves here, and then this is in 0, so it needs to split 1 back, so then my -2 comes back there, right? So then this is 3, and that's my -2. And then my next loop, in the fourth one, then -4, then -4 becomes the larger negative, then I pass it here, it becomes positive, and it ends up here. So that's the type of loop that we're trying to create with our for loops. And then we just bring everything back. So how do we do that? So first we need to initiate our empty list. So we do self.low equal to an empty list, and then self.high is also equal to an empty list. And then from here we wanna do an if statement to start the iteration of the heaps, right? And the population, so we're gonna use push and push pop. And that's gonna first push and then pop, and then we're gonna go through the iteration. So if the length of myself that low is equal to the length of myself that high, then first we want to send it based on our logic. First we want to send it to the lower, right? So we do first we're gonna send it to the, so then we do heap push pop, and then self that low, and then we are putting a negative number in there. So this is our first when we first put it into the negative list. But then we need to make this negative because we are first, so that high yourself to, and we're pushing after. So first we push it to here, heap push, and then heap q, because we're calling the that q and heap push. So this is the proper way to call the library. So heap q, heap push, self high. So what are we doing here? First we're pushing into the low, and we need to make it negative, right? So we get the highest negative number or the lowest negative number. And then after that list gets organized, we push it, we take it out, so we pop it here. That's why we do push pop. So first we push it, then we pop it. We cannot do it backwards, it doesn't work, but then we pop it. And since we're popping a negative number, we need to multiply by a negative, so then we can push it into the high list as a positive. Okay, so that's what we're doing here, and then we're pushing it with this push. So in this parentheses, you take the list and the number. So the number is this, and in this one we're doing the same thing, so we're just calling it within itself. And then here else, we can do the same thing, but we're gonna push it to the high. So first we do, like, here's what it's doing in the loop, right? First pushes one side and then goes back. Okay, so that we have that. And then here we're gonna, so we have this consistent, we're gonna do the same if statement, and then we're gonna return if it's the same. They're asking us for a float in the answer. Somewhere here says float. So here self that high, so that first number minus self that low, self that high in the number, and self that low in that first index, and then we divide this by 2. Else we return, if the list is uneven, we're gonna return the high, because our high list is always gonna have one number more. So set that high 0, and that should work. So let's run it. Let's hope there's no spell. Oh, that worked. So if we submit it, then that's it. It ran pretty fast. I hope this helps. Heaps are really cool, and they work very well for this type of approaches for data. So I hope this video helped you more or less understand how you can approach this type of projects. Thank you.